Hi everyone, I hope you are doing well and welcome to Login Science. This is our lesson 4 of 6 on sequences and series. Today's lesson will be on geometric series. Okay, as always, before I can start with our lesson, I'd like to remind you and encourage you to subscribe to your channel and activate the notification bell so that you can be notified every time I post new content. And you can see down below is my name and the email address at which you can reach me. Okay, so we say the formula to calculate a geometric series is this one. This is the formula we use to calculate a geometric series. So you know A is your first term and R is the common ratio and N is the number of terms. So you have Sn, which is the sum of n terms, S for sum. Okay, so this is the formula you use to calculate a geometric series. Okay, so sometimes you might come across the other formula where they are telling you that you can use this formula when R is less than 1. This one. So actually, it is actually what? The same formula as the first one. So I'm right if I say it is equal to this one. I don't know if you've seen it before. This one. They will tell you that use this one when R is less than 1 and use this one when R is greater than 1. There is no need for that. You don't need to stress. This is actually the same formula. So you can use the first formula for any value of R, whether R is less or greater than 1. The same is true, you can use the second formula for any value of R, whether R is less or greater than 1. You can use this formula for any value. So what you need to do is to only memorize, if you want, one formula. Let's say this one. You don't need to memorize the two formulas. So if you think I'm wrong, I'd like you to prove me wrong. I'm telling you that the first formula is equal to the second formula. You can use this formula for any value of R, whether R is less or greater than 1. Or you can use the second one for any value of R, whether R is less or greater than 1. How did they obtain the second formula? You can see that the second formula is actually obtained from the first one by multiplying by -1 in the numerator and by -1 in the denominator, and then you end up having this formula. When you multiply this part by -1 and you also multiply the bottom part by -1, you end up having this. So can you see that this is actually this part? It's actually times 1. Can you see -1 divided by -1 will give you 1, and then what you are doing is you are multiplying this formula times 1, and then you end up having the same thing. So there's no need for you to stress in knowing the two formula. What we have to do is to just memorize one formula and then you are good. So don't stress in memorizing the two formula where they are telling you that use this one when R is greater than 1 and use this one when R is less than 1. This is actually the same formula. You can use either of them for any value of R. Okay, I hope I'm clear on that. And R must not be equal to 1. You get that? If you have R equal to 1, you're going to end up having division by 0, which is undefined. And R, the common ratio, cannot be equal to 1 because you'll be multiplying by 1 and then you still have the same and the same and the same and the same thing. I don't know if you are getting that. Okay, let's do some example. Okay, example number 1. We have two questions. Let me read the first question. Question 1. Determine 3 plus 6 plus 12 plus 24 plus and so on to 10 terms. 2. if 2 plus 6 plus 18 plus and so on is equal to 728. Determine the value of n. Okay, let's start with the first question. Okay, so you can see this is a geometric series, and you can see there is multiplication by, if you check, there is multiplication by 2 from 3 to 6, 2 from 6 to 12, 2. So this is a geometric series. What are they telling us to do is to determine the sum of the series up to 10 terms. So they are telling us to calculate what? S subscript 10. So we're still gonna use this formula, but we are adding up how many terms? 10 terms in this series. We only have how many? 4 of them. 1, 2, 3, 4. So we can continue up to 10 terms and then we do the sum. So we're gonna use the formula here for 10 terms. Okay, so we want to find S sub 10 or S10. Okay, what is A? You remember A is the first term, and in this case A is equal to 3. And what is our R? How do we find R? We get T2 divided by T1. So T2 is 6 and T1 is 3. So this must also be equal to, if you say 12 divided by 6, 12 divided by 6, or 24 divided by 12. So it is the next term divided by the previous term, and this is equal to 2. Can you see that? So our common ratio is equal to 2. When you take 6 divided by 3, or 12 divided by 6, or 24 divided by 12, it will give you 2. And what is our n? N is 10, because we are calculating the sum of 10 terms. So we have everything here. Now we can calculate our S10. So what is A? I'm using this formula. What is A? You can also check when I'm done with this formula. You'll find that the answer is still the same. So you're not gonna go wrong for any value of R. Whether you use this formula or this one, you're still gonna get the same answer. I'm using this formula. Just follow me as I use this formula. And then in your time, you can also check with this formula if the answer will be the same. Okay, what is the answer? So we're plugging in the values. What is A? It's 3. What is R? We calculated R. It's 2 to the power of n. What is n? 10 minus 1 over, what is R? 2 minus 1. This one. Okay, let's plug in our calculator and see what the answer is. This is the calculator. We have 3, 2 to the power of 10 minus 1. We have 2 minus 1. And this is the answer. 3069. 3069. So S10 is equal to 3069. Okay, this is the answer to question 1. You can still check with this formula. You're still gonna find the same answer. You can pause the video, feel free, and check with this formula. You'll still find that the answer is still the same. Okay, let's do question 2. Let me use this space. This one here for question 2. Okay, question 2 we have, you can see this is another geometric series. There is multiplication by 3 from 2 rather to 6, multiplication by 3 from 6 to 18, multiplication by 3. Can you see that? And we are told that the sum is equal to 728. Now we need to determine what the value of n. Can we still use this formula? Yeah, the formula can work. Let's see. So we're gonna use this formula, or you can use this formula. Okay, I'm sticking to this formula because it's still the same formula. Don't stress out. Just memorize one formula and then you are okay. I have explained how this formula is obtained from this one. Okay, now let's use this formula. S n will be replaced with 720, 28. 728 is equal to, what is A? A is the first term, which is 2. You open. What is R? We don't know R, but you can see, I told you R is 3. If you take 6 divide by 2, it will give you 3. Or if you take 18 divide by 6, it will give you 3. So R, the common ratio is 3 to the power of n. We don't know n. Gonna find it. Minus 1 over R minus 1. R is 3. I've just shown you. It is 3 because you have 2 times 3, 6. 6 times 3, 18. So 3 minus 1. Okay. And this will give you 2, 3 to the power of n over 2. Can you see this is 2? So this 2 and this 2 will cancel. Now you have equal to 3n minus 1. And then when the minus 1 comes this side, so it will be 728 plus 1. We're going to have 729, and then it will be equal to 3 to the power of n. Can you see now we have this 729? You can use log to solve for n, or let's cheat and see. If I have a base of 3, what should I raise my 3 to? To which exponent, so that I can have 729? You can check with your calculator. You can start by raising it to the power of 3. You'll get 27, and then try to raise it to the power of 4 and see what you have. If you don't get 729, continue to the power of 5, and continue to the power of 6, continue to the power of 7 until you get 729. So it should be to the power of 6. If you check with your calculator, this is what you should get. And so this will be equal to 3 to the power of n. So this 3 to the power of 6 is the same as 729. So when the bases are the same, our exponent must be equal. So n is equal to 6. Okay, so the value of n is 6. Okay, let's start by looking at sum to infinity of a geometric series. Let's start by looking at converging geometric series. We said that you can only calculate the sum to infinity for a geometric series only if the series is converging. We'll see that. And we also said that a geometric series converges when Tn tends to 0 as n tends to infinity. We'll see that. And we also said that a geometric series converges if the value of r is between -1 and 1. That is r less than 1 and r greater than -1. Okay, let's say we have this example. We have a geometric series like this one. Okay, you can see in this geometric series, you can see when we start from 1, the value of the terms are getting smaller and smaller. Can you see from 1 you go, so the value of Tn, they are what, tending to 0. So Tn tends to 0, or we can say Tn approaches 0. You can see this value is getting smaller and smaller. It's approaching 0. Let's see, you can see, maybe you are not seeing that because it fractions. Let me use a calculator. Let's start by checking this fraction. If it's 1/32, let me press this so that I can have a decimal. So the value is 0.03125. So you can see the value is smaller. When you check the next term, which is 1/64, okay, let me press this to get the decimal. You can see the value gets even smaller. So the value is approaching 0. That's why we said that Tn tends to 0. So Tn is approaching 0. You can see as you move on. And we also said as n tends to infinity. So n tends to infinity. N, remember, represents the position of the term. So this is n equal to 1. This is n equal to 2. This is n equal to 3. This is n equal to 4. And so on. So n tends to infinity. You can see that this is what we said here. And you can see we also say that a geometric series converges if the value of r is between -1 and 1. When you check what is the value of r, remember r is the common ratio. If you divide the next term by the previous term, like 1/2, you divide it by 1, you're going to have 1/2. You can try with any term. You can get this one, you divide it by the previous, or you get this one, you divide it by the previous. You're going to have 1/2. And you will see that 1/2 is between these values. It's actually a value before 1. Remember, 1/2 is equal to 0.5 or 0.5. So the value is between -1 and 1. So if the value of r is between -1 and 1, the geometric series is converging, or we say it's a convergent geometric series. So, and we can calculate the sum to infinity if the geometric series is converging. And we have a formula that we can use for the sum to infinity for a geometric series that converges. And this is the formula. So this is sum to infinity. You have that symbol for infinity. So we use this formula. It's a over 1 minus r. So this formula is applicable if r, the value of r is between -1 and 1. So you remember your a is the first term and r is the common ratio. So this is the sum to infinity. You use this formula to calculate the sum to infinity. So you can only calculate the sum to infinity when the geometric series is converging. So you know these are the points to check if the geometric series is converging. Okay, let's move on and look at diverging geometric series. Okay, now for a diverging geometric series, we say you cannot calculate the sum to infinity for a geometric series that diverges. Okay, we'll see that why we cannot calculate the sum to infinity for a geometric series that diverge. We'll see that why we cannot. And we also say that the sum to infinity for a geometric series that diverges does not exist. We'll see that a geometric series diverges when Tn tends to infinity as n tends to infinity. So n is approaching infinity, or Tn is approaching infinity. Okay, let's see this example. Let's say we have this geometric series. Okay, you can see the value of Tn, or the terms, are getting bigger and bigger and bigger and big. So this is what we said here. Tn tends to infinity. So the value of Tn are getting big and big. And you can see that n tends to what? To infinity. So this is n equal to 1, n equal to 2, n equal to 3, and so on. Remember, n represents the position of the term. So n tends to infinity. And this is the symbol for infinity. So n tends to infinity. Can you see? It diverges. It means it gets bigger and bigger in value. So, and you understand that we cannot calculate the sum of this. It doesn't exist because we don't have an end. We keep adding, adding, and adding bigger and bigger value. So there is no sum to infinity for a diverging geometric series. It does not exist. You cannot calculate because you'll keep on adding and adding bigger and bigger value. And we say that a geometric series diverges. This is geometric series diverges if r is less than -1 or r is greater than 1. So r, the common ratio, is less than -1 or r is greater than 1. Okay, you understand now why we cannot calculate, because it does not exist, because it keeps on becoming bigger and bigger and bigger without an end. There is no end to this geometric series. You can still continue, but the problem is that the value is getting bigger and bigger. In the case of converging series, the value of the sum will be equal to a certain number because the value of the Tn is approaching 0. Okay, let's look at example number 2. Let me start with question 1. Determine the sum to infinity of the series 2 plus 6 plus 18 and so on. Question 2. Determine the sum to infinity of the series 16 plus 8 plus 4 plus 2 plus and so on for an infinite number of terms. Okay, let's say solutions. Okay, we start with question 1. Okay, you can see in question 1, we are asked to find the sum to infinity of the series. You can see this is a geometric series because you can see there is multiplication by 3 to get the next number, multiplication by 3 to get the next number. But you can see that r, the common ratio, is equal to 3. And this tells you that the value of r is not between -1 and 1. And you can also see that the values of the terms Tn is getting big and big and big. So this cannot be a converging geometric series. This is actually a diverging geometric series. So we are asked to find the sum to infinity of this series. The answer is the sum does not exist because this is a geometric series that diverges. So the answer to this, I'll say the sum to infinity, for the geometric series cannot be calculated because the series diverges. Why? Therefore, the sum to infinity does not exist. It does not exist because there is no ending here. The values are getting bigger and bigger. There is no ending here. So this is a diverging geometric series. We cannot calculate the sum to infinity. So we'll say the sum to infinity does not exist. Okay, let's move on to question 2. We have answered question 1. In question 2, they said determine the sum to infinity of the geometric series, which is 16 plus 8 plus 4 plus 2 and so on, for an infinite number of terms. Okay, let's check first what is the value of r. The value of r is equal to, when you take the next term, divide by the previous term. So that is 8 divided by 16. This must be equal to, when you take 4 divided by the previous term, and when you take the next term divided by the previous term. So it is always the next term divided by the previous term. And when you check, this must be equal to 1 over 2, which is your common ratio. So you can see already the value of r is 1 over 2, and this value is between -1 and 1. 1 over 2 is equal to 0.5 or 0.5. So it is the value before 1. So you can see the geometric series is converging, and we can calculate the sum to infinity. So the formula will be this one. To calculate the sum to infinity, if you remember, we have this formula: a over 1 minus r. This is my a. And what is your a? A is the first term, which is 16. You can see the first term is 16 over 1 minus r. What is r? We calculated r. It's 1 over 2. And this will give you 32. You can check with your calculator. Okay, the sum to infinity of this geometric series is equal to 32. Okay, I think this is all for this video. And don't forget to subscribe to your channel if you haven't. I'd like to see your comment if you have any question. And take care, and see you next time in the next lesson. And bye.